Now, with the vehicle's path, you can find out some very useful information. You can find out the total time or travel time it takes a vehicle to go from its initial location to the end of its path. You can also get the distance or the length of the vehicle's path, and you can use this to your benefit in your scripts. Let's reset, and after we define the vehicle's path, we can then get the total time. So let's print vehicle.totalTime, as well as the path length. So vehicle.path length. And notice I'm calling these two attributes after I define the vehicle's path, because these will reference the current assignment to the vehicle. Compile the code, run the simulation, and now if we check the output panel, we can see that it takes the vehicle about 7.6 seconds to get from here to there, and the total distance is 4,000. Now, if your interpolation value is greater than 0, you will see a change in the vehicle's total time and path length. So if I reset the simulation and set interpolation to 0.6, compile the code, run the simulation, if we check the output panel, you do get a larger total time. So now we're at 8.1 seconds, and the length increased to about 4,400. Let's reset and set the interpolation back to 0. By using these values, you can do several operations. For example, you can tell the vehicle to stop at a distance not at the end of its path. Because if I run the simulation now, if I reset and that recompiles the script, you can see that the vehicle is stopping at the end of its path. But what if we want to stop halfway there? Well, it's easy. You can do that. Let's reset and comment out these lines, or just delete them. And now let's get the distance of the vehicle's path. So d equals vehicle.pathLength. And now we can use our vehicle object to call this method, reset stop at distance. This allows you to change what distance on the vehicle's path it stops. So instead of stopping at the end of the path, let's stop halfway there. So distance divided by 2. Compile your code, run the simulation, and yep, now the vehicle stops about halfway after it gets to point 1. You can also do this using time. If you reset your simulation, and let's comment out this line of code here, or we can just delete them. Let's now create the time. So time equals vehicle.totalTime. We're using the travel time of the vehicle now. And we need to create a delay. So how long do we want to wait before we tell the vehicle to stop? Let's do about half the time, or half its travel time. So we're waiting about half the time, and then we're going to tell the vehicle to completely stop moving. And the way you can do that is by calling that clearMove method. Now remember, this will remove all points from the vehicle's path and completely stop it. Compile your code, run the simulation, and yep, so now the vehicle is stopped here. But what if you don't want to stop the vehicle? You just want to reroute it or replan where the vehicle goes. For example, you might have a mobile robot that detects a possible collision, and you want the robot to go somewhere else to avoid that collision. It's very easy to do that in your script. Reset, and instead of clearing the move, let's tell the vehicle to replan by calling this method. We can now add a control point to the vehicle. So let's change this up. Instead of going to point 1 and point 2 first, let's say we comment out our for loop and tell our vehicle at the start just to go to point 1. So vehicle.addControlPoint, point 1. And then we get the total time it takes the vehicle to travel to point 1. Remember, we're telling the vehicle just to go to point 1 now, so this total time is referencing that path, not the path of point 1 and point 2. So halfway to point 1, we're then going to replan the vehicle and tell it to go to point 2 instead. So vehicle.addControlPoint, point 2. Compile your code, run the simulation, and whoop whoop, you can see the vehicle, it got about halfway to point 1, which was over here, and then it was told to reroute and go straight to point 2, and that's what happened.